Hey everybody, welcome to your Wednesday independent work notes video. Grab your Desmos workbook if you don't already have it. We're on page 52. All right, Mr. Wong, you want to read this first part for me?
Yep. A plant's height is proportional to the number of days since it was purchased. On day 6, it was 3 inches tall. Number 1 says add more points to the graph to represent the plant's height on other days. And we see the point here is on 6, comma 3.
All right, so I'm gonna just kind of make a couple little notes of what I see on 6,3 here. How about I zoom in, because that's gonna be really small on this recording. There we go. So if you've been remembering your graphing skills, the second number in an ordered pair or in a coordinate point is the y value. So I'm just going to make a little y pointing at the 3 there. And the first number is the x value. And so we know that in order to find the constant of proportionality for a proportional relationship, which we know this is proportional because it said in the instructions there, is we do y divided by x. That doesn't change just because we're getting our values from a graph rather than a table. So I'll do this. I'm going to do k equals y divided by x. And so I've got 3 as my y value and 6 as my x value. So what is that? 3 over 6. What's that equal to, Mr. Wong?
I believe it's equal to 1/2. We know that, if we take each of them and we divide by 3 on the top and the bottom, or we see their common factor of 3 and take that out, we will end up with 1/2. And so you got 3, 6 reducing or simplifying to 1/2 there.
All right, so there's our constant of proportionality, 1/2. We can use that to help us find more values that are paired together in this relationship that will create more coordinate pairs on our graph. When you have an x value and a y value that go together in a proportional relationship, that makes points on your graph. So we can make a table and then sort of transfer that information into the graph. So I want to keep everything zoomed in so you can see real nice. I'm going to rewrite just the fact that our constant of proportionality is 1/2 over here, just so we have it on this side of the page. And then I'll make a quick table with x values, which in this case was the number of days since we bought the plant. So I'll put days over here too. And then y value, which is the height in inches. It says IN right here in real small letters, so inches. We already know that after 6 days, the plant has grown 3 inches. How can we find some more values to put into this table and then transfer as coordinate points, Mr. Wong?
Yeah, so we know that using the constant of proportionality means that whatever the x value is, we multiply it by the constant of proportionality, our k value, to get the y value. So in this first example, we have 6. 6 multiplied by 3. If you want to draw that arrow over there, Mr. Thomas.
6 multiplied by 3, is that what you meant to say though?
Multiplied by 1/2, thank you, is equal to 3. And so if we pick another number, then we should be able to get, using the constant proportionality, another y value. So let's say we pick 4 days as our next x value.
Okay.
Now, we know that it's proportional, so we have to multiply by 1/2 again. And we know that half of 4 is 2. And so our inches, and what we're saying here, remember, we always want to relate it back to the real world. After 4 days since we purchased it, the plant's height will be 2 inches. Mr. Thomas, do you want to do one more point?
Yeah, let's do one more, and then I'll put them in the graph. So I'll make another line. Let's see here. Okay. Well, we did 4, so I think another easy one to pick from here would be 8. So I'll pick 8 days, and now I see 2 different ways that I could get this y value from here. My favorite way would be to just multiply by the constant of proportionality, which is 1/2. And so 8 times 1/2 is going to equal 4. But another way you could have seen that answer is the fact that I doubled the number of days from 4 to 8. So we doubled the number of inches from 2 to 4. All right, so now we have two more like associated values, an x value and a y value, and an x value and a y value, and we can turn these into coordinate points over here on our graph. So I'll do the second row first. I have 4 days, 2 inches, so that'll make the point 4 comma 2. So I count carefully 1, 2, 3, 4, and then up to 1, 2. And I'll label this point as 4 comma 2. And then the other pair of values we had was 8 days, 4 inches. So I'm going to go 8 on the x-axis. So there's 5, 6, 7, 8. And then up 4. 1, 2, 3, 4. And I will label this as the point 8 comma 4. All right. So do you think that's enough points that we could connect them and see a line sort of representing this plant's growth, Mr. Wong?
Good. I think maybe we should talk about question number 2 right before that, because we got to find the starting place of where, where this plant first starts in order to draw our line. Is it cool if we do first?
Well, it says, should the origin, also known as 0, 0, be included in this relationship? Why or why not? That's an interesting question. What do you think, Mr. Wong?
Well, I think a great way to discuss this would be to look at the table and to see, let's start with the x value being 0, because we could pick a number 0 and maybe using that we'll see why we may or may not need it. And so to keep this proportional, we have to multiply by the constant of proportionality. So Ms. Thomas, you're doing a great job with those colors. If you can multiply by 1/2, we know that 0 times any number is going to be 0. That is the property of 0. When you multiply 0 by any number, you're going to get 0. And so by definition, if we have 0 in the first quantity, whatever we multiply to it, it's going to be 0. So we do need a 0, 0, or the origin to be in our graph. Ms. Thomas, you want to add to that?
No, I think that's a great way of explaining it. So I would say that 0, 0 must be on the graph of any proportional relationship because 0 times k, that's what we did here. We took 0 and multiplied it by our k, always equals 0.
Couldn't have said it better myself.
What's that?
Couldn't have said it better myself.
So that's sort of a broad answer though, but what does 0, 0 mean for this particular graph? Like what is the point 0, 0 telling us about this like plant and its growth?
So we know x is the number of days since we purchased it, and 0 in the y would be the number of inches. And so what this tells us in our situation is that the day since, if it's 0 days since we purchased, that's going to be the day that we actually purchased this plant. And the day that we purchased the plant, it's saying that the plant's height was 0 inches. And so maybe we bought, some kind of seed that was just about to pop out from the soil. And so there was it was at a 0 height. And so when we bought it, it was at 0 inches in height. And now as we have grown the plant, as we've seen it grow, it's growing in its height as we've gone number of days.
Cool, got it. All right, should we move on to the next one?
Do it. All right. I can do it. It says, this graph shows information about a different plant. Does this relation represent a proportional relationship? Why or why not? What do you think, Mr. Thomas?
Well, right off the bat, I kind of feel like it doesn't meet the criteria that we just wrote in the previous sentence. We wrote that the origin 0, 0 has to be on the graph of a proportional relationship. because of that whole 0 times your constant is always going to equal 0 business. But this one, like this line is obviously above and missing the origin. So to me, that's like the first clue that this probably isn't proportional, but I don't know if that's enough to say for sure. So where do you think we could go from here to check, to be super sure?
Yeah, I was gonna say, maybe we could use a table, find some of the values, and see if there is a k. I mean, we know that if we find different numbers that multiply from the x to the y, then it can't be proportional. So we can use that to see what we get there.
All right, so I'm going to use this area down here where it says summary, and I'm going to make a table with some values that come from the points here. I'll have x values, I'll have y values, and then because I'm checking to see if there's a constant of proportionality, that means I'm going to need to do some y's divided by some x's to see what those ratios are. So I'm going to call this third column the y divided by x, or y over x column. All right, so well, I think I'll pick this point right here.
That's exactly what I was gonna pick.
So this is 1 on the x-axis and 4 on the y-axis. I chose that one because I know 1 is a super easy number to divide by. And so if I've got to divide by whatever number I choose for x, why not choose 1? Mr. Wong, you want to choose another point and then we'll compare the ratios between these points?
Sure. I see 3 in the x and 6 on the y. You can double check my work just in case. I see 3 and 6y.
3 on the x and 6y. I agree with that. Okay, so 3 comma 6. These ratios kind of don't look like they're going to turn out the same to me, Mr. Wong.
It
So
does not. Let's check anyway.
4 divided by 1, that's going to be 4. So the y over x ratio in this first row here is 4. And then 6 divided by 3, the y over x ratio here is 2. So I don't see a constant of proportionality happening here. I see these ratios changing. So I don't think this is going to be a proportional relationship.
I agree, and I think we found 2 really good reasons. 1, because we didn't find a constant of proportionality, and 2, because this line does not start at the origin.
So maybe I should write that as my answers. So no, it's not proportional since the graph does not pass through. You could say pass through or include the origin. Oh, comma, that should be a comma, not a period. And since we found 2 reasons, the y over x ratios, all right, that's these numbers that we checked here, the 4 and the 2, are not constant, right? We found different ratios, so there's not a constant of proportionality, so we must not have a proportional relationship.
Yeah, and there's no k value there, and so those are both really great reasons. We should probably summarize what we've learned here. I think it's clear, one of the things we noticed is that having a straight line is important because it shows some sort of relationship of equivalent ratios. If you're going over by the same amount, you also want to be going up by the equivalent ratio that'll make your graph proportional.
Oh, so the proportionality of the relationship is what makes the line look super straight.
Exactly, because okay. About proportionality related to equivalent ratios, and that means you go to the right and you go up the same amount every single time.
Okay. Cool. Well, I think we've done a pretty good job, Mr. Wong. Do you have anything last words to add?
No, I think we've shown here that we need it to be through the origin, and we also need it to be a straight line as well. So great start to our notes, and we'll continue on from there. Nice job, guys. All
right, so do your IXL skills. See you tomorrow.
Bye.